Welcome to ilectureonline. In our next set of videos, we're going to explore all kinds of applications to Newton's second law. And through these applications, through these examples, you're going to get a very good understanding of how to apply Newton's second law. There's so many different ways in which it can be done. The best way to illustrate it is just go through a number of examples, and so that's what this second set is all about. All right, so starting with number one, we have two objects that are sitting on a horizontal surface. They're connected with a string. The first one has a string attached to it with a little ring, and we pull on the ring with a force of 100 newtons. This one is 14 kilograms, this one is 6 kilograms. The question is, what is the tension on these strings? Now, in order to find the tension on the strings, we probably want to find the acceleration of this system first. And what we could do is we could think of this as one system right here, like so, and we're applying a force of 100 newtons to the right. So let's explore also all the other forces that are acting on this system right here. So first of all, we have gravity pulling down on this mass. So this would be m2g, which is the weight of the 14 kilogram mass. And then we have a force coming down this way, also due to gravity, which is m1g, which is the weight of this first mass right here. And of course, knowing Newton's third law, we can see then that there's going to be a reactionary force, a normal force, which is going to be equal in magnitude of n2g. And here we're going to have, let's call it n2. And here we're going to have a normal force, let's call it n1, which is going to be equal in magnitude to m1g, and of course in opposite direction, so that these forces cancel each other out, so that there is no net force in the vertical direction. So there's only one force left, which is this 100 Newton force here pulling to the right. That's the only net force on the system. Therefore, the whole system will accelerate to the right at some acceleration determined by Newton's second law. So we can start out by saying that F net in the x direction is equal to mass total times acceleration. This sub t here simply means the total mass of the whole system. So therefore, the acceleration is equal to the F net divided by the mass total, which is equal to 100 newtons, divided by the sum of the two masses, which would be 14 kilograms plus 6 kilograms. And so that's 100 divided by 20, or 5 meters per second square. So now we know the acceleration of this system, which of course also is the acceleration of the individual masses. All right, now the next thing we'll want to do is find the tension here, tension 1. And if we draw a free body diagram of the situation, we have these two masses right here. We have M2 connected with a string to M1, and then that's connected to a string right here. We're trying to find the tension over here. And of course, we have a similar situation that if we consider this whole system, we can see that the tension in one is accelerating the whole system, so therefore the tension in one has to equal the 100 Newton force right here. So we can say that tension 1 equals 100 Newton. Now, what would be the tension in the second string? Well, for that, we're going to just simply draw a free body diagram of the second mass. So in this case, we simply have the second mass right here, M2, with a string attached to it, and therefore we realize we're going to have a tension to the right, accelerating M2 to the right. So the tension in 2 only accelerates the 14 kilogram mass. It does nothing to accelerate the 6 kilogram mass. So from Newton's second law, we can say that F is equal to ma. In this case, well, of course, we have the tension. Tension 2 is equal to the mass 2 times the acceleration, which is the same as the acceleration of the whole system. And so we can say that T2 is equal to 14 kilograms times 5 meters per second squared. And so the tension in the second string is 70 newtons. So we have the tension in the first string being 100 newtons, and the tension in the second string therefore being 70 newtons. So that's a really good classic example to show that the tension between masses like this of a system that is being accelerated, the tension only applies to the mass that comes after it, not the mass that comes before it. Okay, and there's example number 1.